There aren't any other x cubed, so we're simply going to transfer that. X squareds. Are there any other x squareds? Nope. Bring that down to the party. X's, awesome. 48 and negative 12. Positive 36x, right? Those are now done. Finally, our constants, positive and negative 64, cancel out, yeah? Let's factor this, shall we? Easiest thing I see is to pull out the greatest common factor, x squared minus 12x plus 36. Agree? This looks like a perfect square trinomial. Looks like it's going to be x minus 6 squared. So it's x minus 6, and for sake of argument, x minus 6, okay? Otherwise known as x minus 6 squared, okay? So the zeros of this equation, x equals 0, which we already know here, and then x minus 6 equals 0, which is a double root. So we've got 0 and 6, double root, okay? 0 and 6. Do not let the f of x, g of x, or whatever x worry you. Finding the zeros simply means replacing the function notation with a 0, solving to the best of your abilities, collecting like terms, and factoring, okay? That is all that is extra to learn today. I want you guys to turn with me to page 196. And I want to do a few more examples. Find the zeros. Find the zeros. 11, and I'll just do a couple with you. Find the zeros of f of x equals 3x minus 12. Replace the f of x with 0. Factor this. Three times x minus 4. So you might say to yourself, 3 equals 0? It doesn't. That's false. So you automatically throw that out as part of your answer. 3 does not equal 0. But I can solve x minus 4 for 0. Therefore, your solution set is 4. Okay, does everybody see why I threw the 3 out? Even though I factored it, this does not equal 0. But x minus 4 can equal 0 as long as x is 4. Okay? That's number 11. Number 12. Solve for 0. G of y, whatever, f of x, who cares? Y squared minus 16. So that means 0 equals y squared minus 16. What kind of a factor job do we have to do here? Difference of squares, good. Y plus 4, y minus 4. Solve both of those for 0, and you should find that your zeros are 4 and negative 4. Okay? That's number 12. Number 13 and 14 are already factored beautifully for you. Please look at those with me. I'm not going to waste time. 13 and 14, you're going to solve 2t minus 3 equals 0. And you'll come up with 3 halves. You're going to solve t plus 2 equals 0. And you're going to come up with a negative 2. Number 14, look at it with me. Z equals 0. Z minus 3 equals 0. Z plus 1 equals 0. You guys can figure those out pretty well, I would say. 17. I want to do that one with you. g of x, and then I still have a few more, so don't leave me yet. G of x equals x times x squared minus 2x plus 1. This is really similar to the one that Esther identified from yesterday's homework. She's looking at this going, well, this is factored, but this isn't. So you would have to factor the x squared minus 2x plus 1, which is a perfect square trinomial. Okay? So all of that equals 0, which means x is going to equal 0 or 1, and that 1 is a double root. Okay? Because x equals 0, x minus 1 equals 0, which is 1, x minus 1 equals 0, which is a repeat, making it a double root. Okay? All right. That should say 2 through 34 even. For Pete's sake, I'm erecting. Okay. Alright, this should say 2 through 34 evens and 39 through 42. Okay, last thing I want to cover with you guys. The last few samples I would like to do with you guys. I would like to do, which one, honey? 18? You want to do 18 in the practice? Sure, I can do 18 in the practice. Okay, class says 18, so here we go. This is still in the practice. F of t, which we're going to just make 0, equals t minus 2 squared multiplied by t minus 3 squared. This here is the same thing as saying t minus 2 times t minus 2 times t minus 3 times t minus 3, all of that equals 0. Okay? The t minus 2's equaling 0 means 2 double root. And the t minus 3 equaling 0 is going to be 3 double root. You might see double 0 too, dz, dr. Either one is acceptable. I don't care. Okay? Double 0 is usually used in function notation, but I don't care. It means the same thing. All right? Let's do number 39. Here's a freebie for you. Pat's going to love this one. He might already have it done. But here's 39. This is actually part of your assignment. And of course, you can do it in the back of your book. It's already there. X minus 1 cubed minus x minus 1 squared. All of that equals 0. So this is back to the other thing, f of x, whatever. Okay, you can't simply say that the answer is going to be positive 1 pentuple root, because this has to be combined with a negative this, and then refactored. Okay? So you've got to do x minus 1 times x minus 1 times x minus 1, and combine it with the negative x minus 1 squared. Okay? That's a lot of work, but you got to do it. So first let's do x minus 1 and square it. That's x squared, negative 1, negative 9, minus 2x, negative 1 times negative 1, positive 1. Okay? That is the result of squaring this. Okay? And isn't that what I need to do over here anyway? Okay? So I'm going to write it in as my solution, just so I don't forget, and you'll see why here in a minute. Okay? The result of squaring x minus 1 squared is here. I squared this, and now I'm going to take it one more step and finish the cube. Okay? So you get x cubed minus 2x squared plus x. All of that is done over here. We've got a negative x squared plus 2x and minus 1. Combine all of that, and you get x cubed minus 3x squared plus 3x minus 1, if I did all my arithmetic correctly. X cubed, negative 2x squared, positive x, negative x squared, positive 2x, negative 1. Looks like it's all good, okay? We've got to combine that with this. The easiest way to do that is to flip all the signs of what's within because of this negative. That makes it a negative x squared, positive 2x, negative 1. All of that, once we collect like terms, equals 0. Okay? Start in a decreasing degree of x, x cubed, gone. Are there x squareds? Yep, 3 and 1, which gives us a negative 4, very good. And if I make an arithmetic mistake, yell at me, please. 3 and 2. And negative 1 and negative 1. Negative 2. What a mess. This one is a lot of fun. I don't really like doing it this way. There's actually an easier way of doing this, but they didn't teach it to you. Pull out the x, and you end up with x squared minus 4x plus 5, right? Minus 2. That's hanging over there. And this looks like 5 and 1. How am I going to get a positive 5? X minus 5, x minus 1. That doesn't factor. Did I make a mistake somewhere in my arithmetic? There's an easier way of doing it. Yeah, well, here's how. Can I show you the way that's not in the book? And if you get it, great. If not, replace x minus 1 with a. That's the way I do it too, but the book doesn't teach it that way. So, all right. That's why I struggle with these later ones, because our book doesn't teach it the way I'm about to, but I'm going to show it to you anyway. Okay, try to get it. If you don't, I'll try to show it to you some more. Bear with me, okay? All right. This thing cubed minus this thing squared is equal to 0, okay? Instead of doing all of this, the way I was taught, and the way I've always done it, is to replace the value of the item that is being cubed or squared, x minus 1, with some other variable. I always use a, okay? That's what I was taught, okay? So now I have a cubed minus a squared equaling 0. You guys with me so far? I know this seems bizarre, but it's a whole lot easier because somewhere in here I made a mistake and now I can't find it. This way is easier, okay? Let's factor this. If I pull out a squared, I get a minus 1. Is that correct? Everybody see that? A squared, a minus 1. Okay? This is a times a. And this is a minus 1. Okay? So we've got a equaling 0. A equaling 1. Okay, but they're saying x minus 1 equals a. So take the value for a and plug it in. X minus 1 equals 0. X minus 1 equals 1. Okay, do you guys see how I came up with two solutions here? X minus 1 equals 0. X minus 1 equals 1. Okay? Solve for x. And notice that you've got 1 and 2. The zeros, therefore, are 1 and 2. Okay, the zeros are 1 and 2. It's a lot easier than that. Oh, by the way, this is a double root. Sorry, I didn't write it. There's 2 of these, which means there's 2 of those. Those are repeated. This is repeated. Okay? Every year I struggle with whether or not I should even show you this method, but I think I just should show you this method from the start. Most of this section here, you're going to find that if you replace the item that is repeated, being cubed or squared or whatever, with a variable, I always use A, solve for the variable, recognizing that what you get is equal to the original scenario, x minus 1. So x minus 1 equals 0, x minus 1 equals 0, which is why 1 was a double root. X minus 1 equals 1, which is that, giving you 2. That's why you have that on there twice. That little tip is handy for this whole section, to be honest with you. How about I do another one? Or do you guys want to start on your own? I can do another one with this A style. Okay. I'm going to do... Okay. Ugh. X squared minus 1 is A cubed. X plus 2, x minus 2 cubed. 41 is actually pretty easy to do the normal way. Okay? 41 is easier to do the normal way. Because here's 41. This is 41. I wouldn't do it the other way. X squared minus 4 cubed. This is already factored. Unlike the one above, where it wasn't factored, this is factored. You might not realize it, but it is factored. X minus 2 cubed, x plus 2 cubed. Because this is a difference of squares. This difference of squares factors to this and this. Because it's cubed, each of those is cubed. Okay? So unlike the double root scenario, we actually have a triple root scenario. Because this is being repeated 3 times. X minus 2 equals 0, x minus 2 equals 0, x minus 2 equals 0. Okay? The original equation. And this is tripled. X plus 2 is 0, x plus 2 is 0, x plus 2 is 0, and it's tripled. Okay? Because that's already factored, I would not replace it with A. But 43, I will do by replacing with A. Okay? I will do by replacing with A. 43 is x squared plus 1 squared minus 4 times x squared plus 1, all of that added to 4. And this item equals 0. X squared plus 1 is what I am going to equate with A. Okay? X squared plus 1 is what I am going to equate with A. Whatever I get for A, hopefully this will work. All right. So I'm going to have A squared minus 4A plus 4 equals 0. A minus 2, A minus 2, right? 2 and 2. That'll give me a negative 4 in the middle. That should work. Okay. So A minus 2 equals 0. So A equals 2, right? A equals 2. That means x squared plus 1 equals 2. Okay? This is where it gets tricky. Subtract 1, subtract 1. X squared equals 1. What is the square root? What can this be then? Or, no, negative 1. Both of those items can square to give you that. Okay? Both of those items can square to give you that. Okay? And those are both double roots because it's a double root here. You can use this twice or, and replace it, you can use this twice. Okay? I know these are tricky, guys. Just do the best you can. Okay? I've given you 39, 41, and 43. So you're stuck with 40 and 42 that are really tough in that section, okay? 40 and 42. 40 you're going to have to replace with A. 42 you're going to factor. Okay? Listen up. 40